Good morning, students. Welcome to the class of mathematics. So today we will see how the numericals of banking of roads or the questions related to banking will be solved. Okay, there is a circular track. Okay, this is a circular track, and this is a banking. Banking means an inclination which is of 30 degree. Okay, so here you can see this is called banking of road. Okay, this theta is the banking. That means the road is tilted at theta angle. This is just made to prevent overturning of cars at high speed, overturning of any vehicle at a high speed. Okay, so let us draw the free body diagram of this car which is traveling on inclined road at theta angle. Okay, this is the normal force which will be acting. Okay, with normal, and when this will be theta, we'll draw a line parallel to this. Okay, then this angle will also be theta. So let us draw like yeah. So this angle will also be theta, okay, the alternate angles. When this will be theta, and we will draw a line perpendicular to this horizontal surface. This is the horizontal surface, horizontal surface, right? Gentle surface. And what is this? This is road, and this is banking. Banking means inclination, inclination, right? So students, when this angle will be theta, this will be theta. When this will be theta, then this will be 90 minus theta. This will be also be equal to same value theta, right? And this is the normal. N is the normal. Normal means normal force is a force acting opposite to the surface of car. Here this is car and this is opposite to the surface. This is always perpendicular. Okay? Normal means always perpendicular, right? If this will be n, and you remember students, what is the if we are drawing the free body diagram, okay, what is the weight of this car? This will be acting in the downward direction here. Okay, this will be acting in the downward direction, and what will be the value of that? What will be the value of that? That is equal to mg. Yes, this is equal to mg. This is weight of car, and if this is theta, this is mg, and then n cos theta. If you will draw a right angle triangle here, then what we'll see, this is the component above is n cos theta. Okay, and the component towards the dotted red line, that is here. Okay, this will be equal to yes, n sin theta. Okay. So here, as per the question, we have almost we have drawn the free body diagram. Okay, but the force which is binding this car to not go away from the track, this is the circular force. Okay, this centripetal force which is acting over here is circular force is mv square by r. So what he will see, as per the FBD. FBD is free body diagram. What is as per FBD? As per the FBD, the forces acting horizontally, horizontal forces are horizontal forces in the left equal to horizontal forces in right. Okay. What is the horizontal force in right? Tell me, students. Yeah, this is mv square by r, this one. Okay, so we'll put the value over here only. Okay, this will be mv square by r. Okay, this is the force through which this banking this banking of road prevents the car to go beyond that circular orbit. Okay, and this is the circular orbit. Okay, the circular orbit. This banking is towards across all the part of the circular track. Okay, we have just considered a section of this. So horizontal forces is mb square by r, and the forces acting in the left is n sine theta. Okay, n sine theta, right? Now similarly, vertical vertical forces for vertical forces, what we'll see, n cos theta. This is the vertical force, n cos theta in the upward direction and mg in the downward direction. So n cos theta will be equal to mg. Okay, let us say the first horizontal, where the horizontal forces equilibrium equation is marked it as 1 and second one is 2. Okay, now what we'll do, we'll just divide it. So dividing equation 1 by equation 2, what we will get, equation 1 is n sine theta equal to mv square by r, right? And equation 2 is this one, right? So what we'll do, students, will divide it. Okay, so when we'll divide, the numerator will be divided by numerator. So n sine theta will be divided by LHS of the second equation, which will be n cos theta, and in the RHS the numerator of the first equation is m p square by r. Okay, and divided by RHS of the second equation, this is mg. So we'll cut the terms n in the numerator. Here m will be strike out. So what we'll get, we will get tan theta. Okay, here we will get tan theta equal to v square by rg, and v square by rg. So mm, here the v is known. The v is equal to the v is equal to 180 kilometer per hour. This is velocity. Okay, and this is radius is 600 meters. So all part is given. Okay, first we'll convert 180 kilometer into meter per hour, right? Meter per second. So we put the values only over here. 180 kilometer per hour. Okay, put a square of that, and in the denominator r is 600 meter into z, let's say 10 meter per second square. Here e equal to 180 kilometer per hour, r equal to 600 meter, and g equal to 10 meter per second square, right? So if you convert this velocity into meter per hour, this will be 180 into 1000, and hour will be 3600. How? 60 minutes into 60 seconds. So this will be coming as whatever the value, and the banking and the theta value, the theta will be the theta is the banking of that road. So that can be calculated by the tan inverse of this value. So this value will be 180 into 1000 by 3600 whole square. This will be divided by 6000. The value of theta, that is banking will be equal to tan inverse of this value. Okay, tan inverse of this value. This will give the banking. So students, this the road is designed at an inclination of this angle, whatever the value. Okay, you can see the trigonometric table to calculate the values. We will find out this value of theta. Okay, so this theta will help you. The designing of road is done in this way so that when the car or any vehicle travels on this inclined road with a banking, this will not overturn. So thank you students. Thank you for watching my channel and always subscribe and keep on learning. Happy learning. Bye bye.